Standard reduction potential E naught. What is the standard reduction potential? Standard reduction potential is nothing but the reduction potential values, the reduction potential value determined for a single electrode under standard conditions. What is standard condition? The standard condition is that active mass of the electrode is 1, that is concentration of the metal ion or concentration of the non-metal ion is equal to 1 molar, or pressure of the gas is 1 atmosphere and the temperature is 298 Kelvin. Under standard conditions, whatever may be the EMF is measured for any given single electrode, that is what is called as standard reduction potential, or this is simply in brief, also in the books it is mentioned as SRP. So, under these conditions the reduction potential mentioned is what we call SRP, and this is represented as E naught, and this is Mn plus by M, standard reduction. Also in some of the books it will be given as SOP. SOP is a standard oxidation potential. Standard oxidation potential. Standard oxidation potential is E naught M by M plus N. For same electrode, SRP is equal to negative of SOP, or what in notation it is E naught Mn plus by M is equal to minus of E naught M by Mn plus. This represents reduction Mn plus to M, M to Mn plus oxidation. So, this will give exactly opposite reaction. So, the magnitude of the potential will be same, but as the electron transfer is in the opposite direction, so it will come out in opposite sign. Okay. This is standard reduction and standard oxidation potential. Then how to measure this standard oxidation and standard reduction? Obviously, if you take one single electrode, you cannot measure any potential. What always we are measuring is potential difference between two electrodes, like zinc copper. Again, same example if you consider, zinc and zinc ions will have certain value of potential, it's their own potential. Copper and copper Cu2 plus will have their own potential, but what we are measuring is not the absolute potentials of any of these two, but what we are measuring is the difference, the potential difference between the two electrodes. That is what we are measuring with the help of a potentiometer, or that is connected in the circuit. Okay. So, here it is not the absolute value of any one electrode is we are measuring, it is the potential difference between the two electrodes is what we are measuring. Then how we are able to write the standard reduction potential for a single electrode? For this purpose, what we do is we take one reference electrode. The reference, what is the reference electrode? The reference electrode is the one whose standard EMF, that is standard reduction potential, is exactly known. An electrode whose EMF is exactly known is taken as a reference, and the other one is measured. How do we do that? That we will see now. Suppose if you have two metal electrodes or a zinc copper couple, again if you have take the same example, This is the cell notation. For this, the reaction is zinc gets oxidized to Zn2 plus aqueous to C1 concentration, Cu2 plus aqueous, 2 electrons, here the concentration is C2 to Cu solid. This is the overall reaction. So, overall reaction we write it as Zn plus Cu2 plus aqueous C2 to Zn2 plus aqueous C1 plus Cu solid. And for this Q, if you write, Q is equal to active mass of copper solid into active mass of Zn2 plus by active mass of zinc solid into active mass of cupric ion. This is active mass of copper solid is 1, zinc ion is molar concentration Zn2 plus by zinc solid active mass is 1, Cu2 plus concentration, which is nothing but now you write it as C1 by C2. And overall cell EMF is equal to E cell is equal to E R minus E L. Actually, it is a potential difference which is nothing but potential of the zinc electrode plus potential of the copper electrode. But here in the copper it is the reduction, in the zinc it is the oxidation. Oxidation potential is a negative of reduction. So, when which is supposed to be E R plus E L, but because in the left hand side it is not the oxidation, it is not the reduction, it is the oxidation. So, we take it as minus. So, it is E R minus E L. E cell is equal to E R minus E L. Now, instead of this, now here what you are measuring, so finally E cell is nothing but the potential difference between the two half cells. To measure the potential of any one half cell, obviously what you require to know is the absolute value of potential of the other. For that, what we use is the now standard reduction potential. When you are talking, this C1 will be 1 molar, C2 also will be 1 molar. Then in that case, E naught cell will be E naught R minus E naught L. Standard EMF of the cell is equal to standard EMF of the reduction minus standard EMF of the oxidation, E naught R minus E naught L. If you want E naught R and so finally what you are able to measure is standard potential difference between the two half cells R and L, that is right and left, or reduction and oxidation, either way you can read it. Okay. But so finally what you are able to measure is the potential difference. But what are the absolute values? For that, what you require is the potential of any one of the half cell to be exactly known. So, for that we use standard hydrogen electrode as reference electrode. Standard hydrogen electrode is used as reference electrode. What is a standard hydrogen electrode? Why it is taken as a reference? Why it is taken as a reference is because hydrogen is the moderately electronegative element. Neither it is highly electronegative nor least electronegative. It undergoes both oxidation and reduction. With certain of the metals and some of the electrodes it will undergo oxidation, in some other electrodes it will undergo reduction. So, it is a moderate element. So, is the reason that it is taken as the reference, and its value, its EMF value is taken as 0. Then when hydrogen electrode which is acting as a suppose oxidation half cell, then that will be 0 and the E naught R. If you measure the E naught cell, then you can from that you can measure the E naught R. Or if hydrogen electrode undergoes reduction, then E naught R will be 0, E naught cell you will measure. So, when this becomes 0 and when you measure E naught cell, obviously that value will be equal to E naught L, that is the oxidation half cell. So, one of the electrode will be hydrogen whose value will be 0, then the measured value will give you the E naught value of the other half cell, right. So, how to construct this hydrogen electrode, that we see next.